Hi all, welcome back. And in this video, we are going to learn about one specific kind of relational operator, and that is called the division operator. Division, as the name indicates, it is represented by this, or you can write it like this. Now, what does that division means? How does it works on the relational data table? So that's what we are going to learn. So let's say for the same relation, if we say that we need to find the SIDs who has enrolled in every courses. So we need to find the SID who has enrolled in every course from the course ID, right? So for these kind of situations, we use the division operator. Now how does it affect, like how does it work, that we are going to see in this video. So let's say we have an enroll table, and in enroll we have two fields, let's say SID and CID. This for now. Now for these are the SID, and this is the primary key for this relation. So S1 C1, S1 C2, S1 C3, then S2 C1, S2 C1, then S2 C2, then S3 C1, and so on. Okay, so this is our enroll relation, and we have one more course relation. So this relation consists of the CID. So this is the course relation, and inside the CID we have attributes like C1, C2, and C3. Okay, so now we need to find the SIDs which has enrolled in each courses. So if we see S1 C1, so C1 is this C1, right? Then we have C2, and then we have C3. So S1 is the SID that has enrolled in each course of CID, right? But S2, we can't say that S2 has enrolled in all courses, because S2 has enrolled in C1 and C2 but not in C3. Similarly goes for S3. So S1 is our output, right? So we can write it something like uh, phi SID CID of enroll. Okay, we are projecting SID CID of enroll, and we are dividing it by CID of course. Okay, so this way we can find out the SIDs which have enrolled in every course, in every courses. Okay, so this gives the SIDs enrolled every course. Okay, so this is the result. SIDs enrolled every course. We can get it like this. Similarly, if we want to find out, let's say we have a project like work on, and we have PID. And each employee is associated with a particular project ID. Okay, so this is what we have. Like we have a table called work on, and there we are having two fields like EID and PID. So EID indicates employee ID and PID indicates project ID. So each employee is working on some project, like even working on P1, even working on P2, then even working on P3, and then say we have E2 working on P1. Okay, so this way we have, and then we have something called the project, and for project we have the candidate key as PID, and here we have all these projects like P1, P2, and P3, and we need to find an employee which is working on every project. Okay, so if we see even, so even works on P1, even works on P2, and even works on P3. So even is the employee which works on every project. Okay, so we can write that phi EID. Why I'm spelling it phi, it is projection. Okay, projection of EID and PID from work on, and we are dividing it by projection of PID from project. Okay, so we are getting the employee ID and project ID from work on, and we are dividing it with the project ID of project, and this gives us the employees who are working on every project. So it gives us EIDs working on every project, working on every project. Now writing like this gives us no sense. what does that mean, how does that division works. So we need to see the inner implementation of the division. So that is known as the expansion of division. How does this division operator works on? Okay, so we are going to see the expansion of division. Let's see. Right. Now, if we see, like if we write projection of SID, CID from enroll, and we are dividing it with projection of CID from course, then we get the SIDs enrolled in every course. SIDs enrolled in every course. Okay. Now how to find it like this, what how does that division operator works? So there are two ways. First, we need to find SIDs who are not enrolled in every course. SIDs not enrolled, not enrolled in every course. Okay, so there might be some SID which is not enrolled in some course, so that we need to find out. Okay, so the first process is SID is not enrolled in every course. So this is also equivalent to SIDs enrolled, SIDs enrolled in a proper subset of course. Okay, proper subset of course. Now what does proper subset of course means? So for the course, it gives the CIDs. Okay, so what we will do here, that see, first of all, I'm going to write the expression, and then going to explain this statement. So how we can find the SIDs which are not enrolled in every course? So for the course gives us the course ID, that is the CID, and we have for every course we have corresponding CID. So what we will do, from enroll SID CID, this gives us the SID and CID corresponding to what SID, what which student has enrolled in which course. Okay, so this gives us a valid combination. From that, we will be subtracting the SIDs, the proper subset, like okay, just a second, let me rewrite it once again. So we are trying to find out those SIDs which are not enrolled in every course. Okay, those SIDs which are not enrolled in every course. So let's say we make a combination, we take the SID from student. Okay, we are taking the SID from student, and we are cross multiplying it with the CIDs from course. So this gives us the SID CID combination. So for every student we have all combination of course. So if there is S1, then we have S1 C1, S1 C2. For all course we have a proper combination for students, right? From that, we are subtracting phi SID CID of enroll, the valid combination. Okay, so this might contain some invalid combination. From that, we are subtracting the valid combination of course. Okay, so this will give an example, will give you an idea. So let's say we have the enroll and all possible combination of that. So this, from here we can get something like SID CID, and for every SID we are cross multiplying it with every CID. So if there are three courses and three students, so it will be something like S1 C1, S1 C2, S1 C3, and then we have something called S2 C1, then we have S2 C2, then we have S2 C3, then we have S3 C1. Okay, S3 C2, S3 C3. Now this is the overall combination of all the student ID matched with every courses. Okay, now from here we are subtracting the valid combination. So valid combination we can get it from the enroll. So this is the combination that we created, dummy creation, and this is the actual SID CID mapping, right? So S1 C1. So this is coming from enroll. Let's say so S1 C2, S1 C3, and then we have S2 C1. Then we have S2 C2, and then we have S3 C1. Okay, so we will be subtracting these tuples from here. So we will be subtracting S1 C1 from here. Okay, we will be subtracting S2 C S1 C2 from here. We will be subtracting S1 C3 from here. Okay, we will be subtracting S2 C1 from here, right? We will be subtracting S2 C3 from here, S2 C3, and then we will subtracting S3 C1 from here. So S3 C1. Now whatever is remaining is giving us the wrong combination, which are actually not present in enroll. So what are those? So those are S2 C2, S2 C2, S3 C2, and S3 C3. Okay, so these combination are actually not present. So these are the SIDs which are not enrolled in corresponding course. Okay, so from here we get that S2 and S3, these SIDs are not enrolled in all the courses. Okay, so this gives us SIDs not enrolled in every course, right? And what does that means? That SID is enrolled in proper subset of course. Proper subset of course means if we have a subset and it does not includes all the courses, then those are proper subset. So this is the proper subset of course. So these SIDs, these are the SIDs not enrolled, not enrolled in every course. Or we can say these as these are the SIDs which are enrolled proper subset of course, proper subset of course. So this way we find first part, and in the second part what we will do, we will subtract this SIDs from the enroll part. So in the second we are subtracting the SID CID in of enroll. We are taking the SID CID of enroll, and from there we are subtracting those SID CID combination which are not valid. Okay, so now this gives us the SIDs which have enrolled in every course. Okay, so this is how it is being written. So now we can write it like, okay, if we are subtracting not SID CID enroll, actually we are subtracting this part. Okay, let's say, let's term this as something called let's term it as a row T1. Okay, so row T1 is this. So we are subtracting from here uh, SID CID of T1. Okay, temp1. Or let's write it, rewrite it again. So it is something like written as pi SID CID of enroll divide upon pi CID of course, and that is equal to, we are subtracting the valid SID CID from the valid SID CID. We are subtracting the combination which which do not have enrolled in any course, which do not have enrolled in all the courses. Okay, so we are subtracting SID CID, and from here we have so this is pi SID CID, and from here we take the pi SID student into pi CID course. Okay, and this minus pi SID CID of enroll. Okay, like this. So and overall we are taking the um overall we are taking the phi of projection of SID. Or in short we can also convert it in short, like we can write it as phi projection of SID CID of enroll, and it is divided upon projection of CID of course, and that is equivalent to uh, first we are taking the SID from enroll, and we are subtracting the SIDs from pi SID of enroll into projection of CID from course, and minus projection of sid cid from enroll. Okay, so this way. Now please note that here we have used enroll table, and earlier we were using a student table, but enroll also contains the sids, so we can use the enroll table as well. Okay, so yeah, this uh, gives us the division expansion, and we can also further write this division expansion, we can further simplify it also. So we can write it like let's say we have a projection of AB from R, and we are projecting B from S, and this can be written as projection of A from R minus projection of A, and in bracket we are taking the projection of A from R into projection of B from S minus projection of AB from R. Okay, so this is a simplified version, so you can remember it like this. It's not needed actually to remember, but yeah, you can keep in mind like this. Okay, so similarly, if we have some relation like R, which consists of A, B, C, D, and then we have a relation like S, which consists of CD. So CD is the common attribute. So if we write R divided by S, then we can do something like phi AB from R minus phi AB from phi projection of AB from R into projection of CD from S minus projection of ABCD from R, and this like this. Okay, so yeah, this is the way. In other ways you can write it like something like projection of what is this, projection of R minus S from R minus projection of R minus S, and then projection of R minus S from R into S minus R. Okay, like this. So yeah, this is all about division operation, and we will be seeing some questions depending on to the relational operation, like how to write the relational algebraic query in the upcoming video. So yeah, that is all for this part, and we'll see some questions in the upcoming video based on the how to write the relational queries uh, corresponding to the statement. Okay, that's it. Thank you very much.